Hello everyone, welcome to this video. In this video, we shall be looking and learning at a result which tell us to find the subgroup of the direct product of groups, right? So here, if we have R as the divisor of M and S as the divisor of N. Now what is M and what is N? So suppose we are given this direct product of two groups, right? Finite cyclic groups. First one is Zm, where M is the order of this group, right? And we have R as the divisor of this M, right? And we have Z as the subscript of this or the order of the second group, and we have S as its divisor. Then a subgroup of this direct product would be isomorphic to. What would be that subgroup? The subgroup is obtained when we take the direct product of M upon R, the subgroup which is generated by M upon R, direct product with the subgroup which is generated by N upon R, right? And this subgroup would be isomorphic to the subgroup ZR with ZS. So basically M upon R would have order which is R, and N upon R would have order which is S. So this result would be more clear through the help of an example. So let's see this example. Here we need to determine the subgroup of this direct product of groups. So here Z30 direct product with Z12 is given to us. Z30 is the group of integers modulo 30 under addition, and Z12 is the group of integers under addition modulo 12. So we need to determine that subgroup of this group which is isomorphic to this group Z6 and Z4. So what is that? So now you can clearly see that 6 divides 30, right? And 4 divides 12. So this 6 is a divisor of 30 and this 4 is a divisor of 12. So it satisfies the conditions of this result, right? Now according to this result, we would have a subgroup of this group which is obtained by dividing 30 by 6. So you know 30 by 6 is 5. So that means the first subgroup of this group Zm would be the group which is generated by 5. So we see that this group which is generated by 5 is a subgroup of Z30, because you know Z30 contains all the elements from 0 to 29, right? From this subgroup here, we are saying the group which is generated by 5 is a subgroup. How? Because you see when we use this 5 as the generator of this group Z30, so we see 5 into 1 is 5 mod 3. So these are the elements which is present in the subgroup which is generated by this, and you see clearly this is a subgroup of this group, right? And what is the order of this group? The order, because this is a cyclic group, so its order would be equal to the order of its generator, which is 5. And you see what is the order of 5? When you multiply 5 by 6 and take it under mod 30, because that is the group operation that is defined to us, so you get the identity of the group which is 0. So therefore 6 is the order here, correct? In a similar manner, for Z12 we have 12 divided by 4 here. So we have 3 as the number. So that means we would have a subgroup which is generated by 3 in this case, right? So this subgroup which is generated by 3, it would be a subgroup of Z12. How? You see in Z12 we have all the elements 0, 1, 2 up to 11, right? So if we take 3 as the group, so all the elements which are generated by this 3 would be 0, 3, 6 and 9. You can see here clearly. So here you see the generator 3 has the order 4. Why? Because when you multiply 3 by 4 and take it under mod 12, you have 0, which is the identity of the group, right? So here its order is 4, and moreover the order of the generator is equal to the order of the group which is generated by the single element. So therefore its order is 4. Hence we obtain two subgroups, one for Z12 and one for Z30, such that we are now able to write the subgroup of this direct product. According to the theorem, it is given by this relation. So we have the value of M here as 30, the value of R here as 6, so that when you solve this you would have 5, and you have the value of N as 12, the value of S as 4, so when you divide this you have 3. So that means this is the desired subgroup which is isomorphic to Z6 and direct product with Z4, and this is what we wanted to calculate here. So I hope you understood this result well. Well, that is it for this video. Thank you for watching.